I proposed this talk called Elm, Fable, and the Practical Implications of Programming Language Philosophy, which I never actually expected to be accepted at any conference anywhere. So I'm quite pleased that someone has actually turned up to this talk. And basically, a lot of what I wanted to do in this talk is, as programmers, we can get very obsessed with either the theory of things, why they're mathematically correct, or kind of the best practice of things, what are the sort of technical trade-offs and benefits. Whereas actually, I've been spending a bunch of time working with Elm recently and with Fable in the past. And one of the things that came out to me was about the very different personalities of the two people who created these languages and the knock-on effects that had going forwards. So there is going to be a bit of technical stuff in this talk. We will be talking about some of the actual technical language features of the two languages, but in many ways that's not really the goal of this talk. The goal of this talk is almost to try and get us to look a level higher up, how we operate almost socially as developers and how we think about things and how we communicate those ideas to other people. And so we're going to look at kind of like the two people involved, the two kind of lead characters in our story. We're going to have a look at what goals they had when they set out, what the philosophy they kind of built from those goals was, how am I going to achieve this goal? And then we'll start talking about some of the nitty-gritty bits about what differences did that make in how they implemented their languages, what differences did it make in the tooling, what differences did it make to the ecosystem that formed around it, the kind of people who chose to use these languages and what they chose to do with them. And finally, the one which actually kind of kicked this whole talk idea off, how it changes teams that use these languages and how they use them. So let's start off. Just want to cover one thing quickly, which Don kind of covered quite a lot of in his keynote, so I won't linger for long here, is why compare Elm and Fable? There are lots of languages out there and lots of ML languages. And probably the biggest thing is that this is a complete program in Fable, which is Fable is FSharp's JavaScript compiler. It's a bit small, I know it's a bit small, and I'm not really expecting you to read the whole thing, but this is a complete interactive web page written with a library called Elmish. And Elmish, not too surprisingly, is based on the Elm architecture, and this is the same program in Elm. And so we have our model, and we have our update, and we have our view, and we have a bit of boilerplate, which basically just says, here's where to inject my view into the HTML that is being served up. And if we flick back and forth, you can probably see that there is a lot of similarity in these two implementations. So it would be easy to take away from this that these languages are very similar. I'm going to posit that actually they're not. They're very different languages, and they get used in very different ways. So we're going to be talking about people, and I'm going to sort of start from this thesis point that programming language design is like interpretive dance for computer scientists. It's a way that you express yourself, you express how you feel, you express how you think without actually telling anyone, because that would be too boring. And so we have two people who we're going to be talking about. So hopefully you all recognize Don, but given he gave the keynote this morning. If you don't, this is Don Sign. He created FSharp. He, at the time, was working for Microsoft Research, and we'll talk a bit about sort of the goals he had in mind. And this is Evan Czaplicki, who created Elm, and is currently being employed to work on Elm sort of full-time by the company I'm currently working with in the US. I'm not working in the US, but the company is. And we're going to have a quick look at their stories and how they influenced each other as well, because there is influence in both directions, and see where we get to. So what were these guys trying to do? What was the target they were aiming for when they sort of started on this journey of, I've got this problem, and the thing I need to solve this problem is a programming language? you might get as far as like implementing your own list in a weekend just because you want to see what it's like to write an interpreter. But you don't generally sort of write your own fully compiled, strongly typed functional programming language over a weekend just because you feel like it. You normally have a goal that you're trying to achieve. And so for FSharp, it had sort of quite a defined goal, which was that, sorry, how many of you use .NET on a sort of fairly regular basis? Chunk of you, okay. So FSharp had a fairly defined goal. So Microsoft this is sort of back in the 90s, Java had come out, Microsoft were going, hey, that's kind of quite a big thing, we should do something about that. And they came to this decision that they needed to have a sort of a runtime that they could run multiple languages on so that they could kind of have this Java competitor, but because Microsoft already had Visual Basic and they wanted something that was a Java equivalent and they already had C++, they wanted something where they could sort of skim down that engineering effort to build a single runtime to run all these languages on. And so they built the Common Language Runtime, the CLR, which now normally just gets called the .NET Runtime. And they had big plans. They had big plans to release a lot of languages on this runtime. And initially, even one of the plans was to release Haskell.NET on the .NET runtime. But there were a few kind of issues with this. And one of the big ones was that it turned out that you could quite easily write a Haskell compiler that compiled down to CLR bytecode. And in fact, I believe they did. I think you can even go and still sort of download. I'm not sure whether it's still available, but definitely at one point there was kind of a Haskell.NET implementation. Don't know how complete it got. But the problem became that although in theory you could run it on this runtime, it had really no interop story with the other .NET languages. You know, you couldn't take a piece of Visual Basic code and go, hey, I want to call this from Haskell. You know, what does that even look like? Or, you know, I've written my nice type class in Haskell. What does that look like in Visual Basic when someone tries to consume this compiled library? And so this question came up, and Don was working at Microsoft Research, and then one of the things which came up was, okay, well, we won't go for sort of Haskell.NET, but we do kind of still want a functional programming language somewhere, and we also want to kind of bring in this concept of what .NET calls generics and what other people call parameterized types that will be common sort of across the runtime. So in the first commercial release of .NET, .NET 1, there was no sort of generic list construct. You couldn't have a list of type T and then tell it what T was afterwards. All of the collections kind of operated on objects and you cast them back and forth as you pulled them in and out of objects. So they went, okay, we want to do something about this. And so Don was one of the people tasked with investigating how could we bring parameterized types into .NET. And he needed a few things for that. One is that he kind of wanted a language where he had a well-known good set of semantics for sort of how parameterized types worked and how you used them in a language where it was natural to use them. As he was saying this morning, he had a background in sort of ML-based languages. So his first thought was, well, I could go with OCaml. And the other reason he thought that is OCaml has a relatively simple compiler. And he wanted the simplest possible compiler because he was going to be trying different techniques for what, you know, mangling the compiler in different ways for how do I want to do this? You know, how do I want to interface between OCaml and C#? How do I want to handle generics? What compiled bytecode would I want to see for a generic list? You know, it's sort of, what am I doing with these things? And how would we need to change the runtime to support this? And so he had this goal of a language that he liked, a language with a simple compiler, and a language which could interface directly with the other .NET languages. It could directly consume code from them, and it could compile down to libraries that could be directly referenced from them. So that was Don's goal in all of this. Fast forwarding a fair number of years, Evan had a very different goal when he started thinking about Elm. So Evan, as part of his thesis, did his thesis on functional reactive programming. So this was not sort of a new thing on a theoretical level. And there were already various libraries available as sort of embedded languages in Haskell where you could write functional reactive UIs. So he was sort of looking at this and he was thinking, this is a fantastic way of simplifying UI creation. So, you know, he was coming into this at a time where, say, if you wanted to write a web page, you know, you'd be firing up jQuery and you'd have lots of events and you'd have lots of independent components and each component would manage its own state. And that was fine and actually quite simple and quite encapsulated until your web page had dependencies between your components. And then everything went down the toilet, basically, because you sort of had this amazing combinatorial complexity of cascading events that sort of got transmitted across these things, and you didn't really have any way of managing them. And so he said, oh, functional reactive programming looks fantastic. But then he also said, well, the problem with this is that they've all been implemented as embedded languages in Haskell, and I have two problems here. One is, I'm not sure I really want to write a Haskell to JavaScript compiler, and the other is, if I'm saying that I'm doing this to simplify UI development for the kind of person who's knocking together a website in jQuery, they're probably not going to want to start their introduction to my new, wonderful, simple way of writing UIs with a deep dive into type classes. So what am I going to do about this? And as he started thinking about it, you can actually go and read his thesis paper. It's fairly readable. It's quite a nice paper to go and have a look at, and quite different from how Elm actually turned out, some of the ideas in it. But one of the things he spotted very quickly is that if I effectively take out the IO monad and I make that my runtime, and I don't, you know, in a way like Haskell does, you can't sort of directly do things with IO only via the monad. But if I make that a runtime and I control where kind of events happen and where the world can interface with your code and where your code can interface the world, and if I take that out of the equation, I can create this pure functional language. And if the language is totally pure, then in my runtime, I can make a whole load of assumptions about your code, which will allow me to generate very small and very efficient code in the compiled JavaScript output. So he basically had two things. He had this goal of, I want to bring this new idea to a group of people who wouldn't otherwise be able to access it. And to do that, I need to lower the bar of entry to this way of thinking. And that was kind of his philosophy, his goal of, I want to bring this in. And so they came up with two very different philosophies of language design. So they both liked similar syntax, so they both used the ML syntax, and they both like functional programming. So in either language, it's much sort of easier and more concise to write in a functional style than it is to do anything else. But their priorities were very different. So Don mentioned this paper that he's drafting at the moment in his keynote, which is a paper he's written up on the early history of F#. And he was saying, by far the most wide-ranging design decision is easy to miss in retrospect. F#'s #1 design choice was to be a .NET language. Everything else was to be subservient to that goal. And Don gave a talk at a bunch of conferences, it was either last year or the year before, called the F# Path to Relaxation, where he actually talks about this in more detail, where he actually sets out this philosophy of having decided that he needed this interop, this was the overriding design decision, that his philosophy had to be, how can I draw together the best parts of these different ways of doing things? How can I make them mesh in a way that not only is possible, but which actually brings out something that is better and bigger than the sum of the parts? And I find this fascinating because this, to me, having met Don personally a few times and had a chance to share a beer and sort of talk politics and family and things, this to me very much fits with Don's personality. So Don is Australian, but his wife is not from Australia. They've moved to the UK. If you read his tweets, he has very strong views on Brexit or not Brexiting, depending how you want to look at it. And this same kind of belief sort of plays out in how he views the world as well. You know, he believes that people should work together. He believes that different cultures have strengths and they can come together and they can do things which are bigger than any one of them would do on their own. And I just find that kind of, I find that very curious how it kind of plays out in his language design. Evan had a sort of a very different philosophy for Elm. So this is from a talk he gave a few years ago called Let's Be Mainstream, in which he was talking a lot about how he was trying to make sort of Elm accessible. You know, how can we sort of introduce it to JavaScript developers or even to non-developers and have something that sort of they can use, they can do things with. And these were the two sort of key things I came away with, which I found interesting. So one of them is a simpler foundation produces simpler code in practice. So this came up with the fact that Evan gets asked, as far as I can make out, about every 32.5 seconds, why Elm doesn't have higher kind of types, which we'll come to in more detail in a moment. And there are lots of reasons. But the very simplest is that you can use type classes and higher kind of types to implement basically everything. And in the Haskell world, you do. But that also means that if you actually try and dig into even quite a simple piece of Haskell code as a complete newcomer and go, why does this work? You can quickly end up in this kind of stack of abstractions that you need a great deal of sort of functional programming theory to understand. You don't need it to use it. You know, it's quite possible to give a sort of practical implication, practical introduction to Haskell. How do I make it print hello world? But to actually, if you ever get curious and you suddenly go, hey, I want to know how that works, you're in for a sort of world of pain if it wasn't what you were expecting. And so he said, not yet. I have this use case for this tool I'm building. I'm not sure that this use case needs sort of higher kind of types. And this was the quote he gave, you know, simpler foundation produces simpler code. And it's not the only place in Elm where he has deliberately left out functionality, not because he doesn't see the value in it, but because he's not sure whether Elm needs it yet to do the job that Elm does. And the other one I find, again, fascinating, it sort of plays a bit into who Evan is. Evan is a sort of very precise person. He's he comes across as a very deliberate person. If you watch any of his videos online, his presentations are always top-notch. And in fact, when he was working on Elm for a long time, he was working for a company called Prezi, who did online presentation software. And he kind of brings that view of an experience through into the language design. He wants to bring that to the programmers who are using Elm. So he's talking about tooling, but he's not just talking about tooling. If you watch the talk, he's not just talking about tooling here in terms of separate programs around Elm. He's talking about the Elm compiler itself as part of this tooling. And so his philosophy was, it should be a delightful experience to write Elm. You know, it should be nice. Even if you're a beginner, or even if you've got a large code base, you should be able to enjoy writing Elm. So let's see how some of these things played out and how they've kind of led to differences and similarities between the languages. So as a first one, let's have a quick think about higher kind of types. How many of you would be confident in giving a definition of what the difference is between a parameterized type and a higher kinded type? Not very many of you. That's fine. I had to think for a while about how to do this. So if we have a quick look here, this is a piece of Elm code. We'll talk about what's called and then in a moment. But you've got this function. It takes a function of something to maybe of something else. It takes in a maybe of the first thing and returns a maybe of the second thing. Make sense to everyone? So if I want to pass that function to something, we're in a functional programming language here. In Elm, I can do that. I can have a function that will take an argument of that type written up the top there. Now, what you can do with higher kinded types is rather than saying a maybe of B, I can say I'm willing to take any function that goes from A to something that takes a single type parameter, an instance of something with that same, that same wrapper type, whatever you want to call it, and it will create another instance of that wrapper type with a different parameter applied to it. So here, we can specify that we want an A to maybe B. In Haskell, you could say, oh, I want anything. It could be an A to maybe, an A to list of B, or it could be an A to option of B, and I could write a function that could take any of those. But to do that, I need to be able to specify that I'm willing to take a sort of generic type that take and how many parameters that type needs. I think hopefully that made some sense. So it turns out neither Elm nor FSharp have higher-kinded types. FSharp kind of bends the rule slightly, but in general, neither Elm nor FSharp have higher-kinded types. And so this means that, for example, in the Elm core libraries and in the FSharp core libraries, you'll see a bunch of standard functions that get kind of repeated across multiple modules. So, you know, in FSharp, you have array.map, and you have list.map, and you have option.map, and so on and so forth. And again, in Elm, you have sort of option.map and things. And the question might be why? Why would you not implement these things? It's not that, you know, if you go back and you read the research paper, it's not that either Evan or Don was unaware of higher-kinded types. And it's not that they didn't know how to implement them. They both worked in environments when they were working on these languages where, okay, it would have added a bit of work, but there were known good implementations of how you could do this. So why did they choose not to? Well, for Evan, it's because he wanted the simplest possible language that achieved the job he wanted. And he wasn't expecting people to be going off and writing hundreds of custom monads. So he said, well, actually, for now, let's leave it out. Let's see how far we can get without it. You know, I haven't released version 1 of this language yet. I can always add them later if we find some use case where actually we really need these. How far can I get without it? And the other thing he did was, you know, talking about sort of monads, rather than, he was also saying, you know, it's like, maybe we don't want these super generic names. So maybe there are some things we want to give common names to, but other things we don't. And so, you know, how do JavaScript programmers think about monads? Well, generally they don't under that name, but what they do think about is async programming. And when they think about async programming, they think about callbacks. And so what he did instead was, rather than add bind and return, he added to most of the core library types that you would expect to be monadic if you came from Haskell, he added an and then method. You know, take maybe of A and then unwrap it, do something else, and you get another maybe back. And so he translated this into the language of kind of callback functions. And so you can write code like that. Don had a different reason for not adding higher-kinded types. Don's reason for not adding higher-kinded types is that no one's thought of a nice encoding that you can give them that makes sense in any of the other .NET languages. So his limitation was not primarily philosophical on this one. I suspect, you know, as he was saying today, it was kind of like, yeah, I'm still exploring ideas with this. It was about the practicality of my overriding design goal is this ability to work together with the other languages, and higher-kinded types break that so far. You know, I haven't thought of a translation that works. But Don's goal was not necessarily simplicity. I mean, FSharp's not a huge language. He's pretty selective about what he includes, but simplicity wasn't his overriding goal. So what FSharp does include, talking about this idea of sort of bringing the ideas together, is he goes, okay, well, we don't quite have higher-kinded types, but maybe we can make use of some of the object-based programming aspects of FSharp to provide the core functionality we really want that type classes are sort of most often used for. And so in FSharp, Don added kind of an equivalent to do notation, which is called Computational Expressions in FSharp, because it's not always a monad, but that's kind of slightly beside the point. And interestingly, the way that you implement this in FSharp is this is the option monad. So if you've never built a monad before, this may not immediately make sense, but just be aware that, you know, this is a mechanism where you can put your own monads into the F# language. And what happens is you actually create a class which has members for your bind and return methods, and it can have a whole load of other members as well, but those are the kind of two compulsory ones. Then you create an instance of this class, and then there is this special notation where you can put, you you use your instance of your class. So this isn't a keyword. This is just this thing here I've created in memory, constructed in memory. You put your square curly brackets, and if you do let bang, what happens here is that with the stuff to the right of the equals sign, it passes this as the monadic type, so M up there, to the member on the class, and it takes the rest of the body of this function and passes it as the callback function, as the continuation function to F. Hopefully that made sense. So, you know, he was going, okay, HiConnie Types, okay, I see uses for them, but what's the big thing we're going to want? We're going to want some kind of monad notation, especially because FSharp was also kind of the testbed for async on the .NET runtime. So this was kind of how he implemented async with a nice syntax. One of the things that, in this sort of interplay going back and forth, one of the things which I find very interesting is that one of the reasons that Evan decided that he didn't need do notation was that the Elm community picked up the forward pipe operator from FSharp, and Evan noticed that if you flipped the arguments on bind, so and then is basically what you'd normally call a bind function, but for those of you who are familiar with it, you'll see the first two arguments are flipped. And that's because what you can do if you do that is you can take your monadic thing and you can pipe it into your continuation function just by putting and then in front, and you can just build a pipeline of these. You can just go and then this, and then this, and then this, and you can build things like, so here it would be sort of some kind of validation method where if everything validates, you get some value out, and if it doesn't, you get none at the end of it. And this does have limitations. So for example, if you ever end up in a situation where you want to kind of like bind two values from two different places and then use them together in a function further down, it gets a bit ugly. But Evan's take for Elm was, that's good enough for now. We'll start with this and we'll see if we are required to add more complexity. And yeah, so this is an interesting one, talking about simplicity. FSharp has a single sweep compiler. And, sorry, I just need to take a drink. The original purpose for this was very simple. Don needed a compiler that he could quickly experiment on. So he hacked one together and off we went. Whereas Evan made a different call on that one, because although his overriding goal is simplicity, his overriding goal is simplicity for the user, not necessarily simplicity for the implementation of Elm. And so Elm has what you would initially sort of go for as a more complete solution to this. So the practical implication of this is that in FSharp code, you cannot reference something that you have not defined further up the program. So FSharp programs always have a very kind of distinctive shape. You have your types at the top, because you can't do anything until you've defined your types. Then you have your kind of nitty-gritty low-level functions in the middle, which actually do the kind of, talk to the database, write things to the disk, all those kind of things, where you build up all of your kind of business model. And then at the bottom, you have your kind of high-level logic, where you put together all of this low-lying underlying stuff. And any FSharp program will, by necessity, have to be laid out like this, because if you write it any other way, then the compiler won't compile it. Whereas Elm, you can do what you might consider the sort of more normal technique of you have your sort of top level important functions at the top of your file, and then as you go down the file, they get sort of more and more nitty gritty and detailed and fussy as you go further. And this was an interesting one for me again, because this kind of sort of talking about emergent design, sort of years later, Don kept on getting asked, why can't I write my program in the order that I want? And one of the things he noticed was he actually did some analysis on some code and discovered that actually the cyclometric complexity in FSharp code is massively, massively lower than in the other .NET languages. And when he started investigating why, it basically boiled down to the fact that most people who come into FSharp don't realize that there are a couple of escape hatches where you can write cyclometric code, but they're quite hard to find deliberately. Their syntax is a little bit obscure. And so actually, if you're a beginner in FSharp, you can't write code with cyclic dependencies. You know, the basic syntax you pick up in the tutorials at the beginning just doesn't allow you to do it. And so he actually decided to keep this as kind of a design feature, which I found interesting. And the last one is enforced purity. We've kind of talked about this a bit already. So Evan wanted and needed kind of complete purity in Elm. And in fact, even in the latest kind of point release of Elm, he's kind of removed yet another escape hatch for being able to sort of embed native JavaScript. And the reason he needed this is because, again, it comes back to the goal. What was he trying to achieve? And his goal was, I don't want the programmer to have to worry about optimization. I want to give them this really simple design pattern. And if they follow it, they will get small, fast, and efficient code. And I can only guarantee that if this code is pure with this technique. So basically, I don't think that was ever really a question for Evan. You know, he kind of needed a pure language for the whole point of why he was writing it in the first place. Whereas Don went a this different route. You know, it's kind of like, okay, my overriding priority is interop. And this is where we sort of start moving a bit beyond the specifics and sort of into decisions that then impacted heavily years down the line. So when Alfonso was writing the Fable compiler, it's like, okay, I want to take FSharp AST and I want to compile it into JavaScript, but I also want to be able to sort of pull stuff in from JavaScript. How do I do that? You know, he obviously, one of the things he looked at was Elm. And Elm has this idea that you cannot synchronously call external JavaScript. You have you sort of have this loop where you send messages and they come back into your update function. Sorry, you send commands and then messages come back into your update function, sort of, and it goes round. So from your update function, you can send out commands to a port, as it's referred to in JavaScript. A port to JavaScript, as it's called in Elm. And then sometime later, you will get a message back via that port that comes back into your update function. And that's kind of the only way of doing it. So you can't sort of ever synchronously call JavaScript. Whereas Alfonso kind of had a look at, okay, how do I want to do this in Fable? You know, do I want something similar? Do I want to kind of build this stuff in? And his answer was, well, no, not really. That's not kind of how FSharp does stuff. And I'm writing an FSharp compiler. And so the solution he came up with was actually very neat and very simple. And it looks something like this. So JS native here is actually a sort of a function that has no implementation. It's just a generic function from anything to anything else. But the Fable compiler knows when it hits it that this is a piece of code that doesn't have an FSharp definition. And so what it then does is it looks for the emit attribute on that function, and it emits a chunk of JavaScript as a little kind of substitution template. So this, for example, might be how you might choose to write a wrapper over jQuery for Fable. And this means it's really, really easy to write JavaScript interop code in Fable. It's also easy to shoot yourself in the foot because obviously the types that are up there are types that you are kind of telling the compiler, just trust me, the JavaScript will fit that type. So that can get a bit interesting. But again, these sort of decisions from very early on sort of flow down through the whole language, and they flow down even how people extend your languages into new contexts and into new places. So that's kind of how these two philosophies and these two goals led to differences in the actual languages. But in a way, what I find more interesting in some ways is how they also change the surrounding bits. So for example, tooling. So if you remember, one of Don's choices was, okay, my primary thing is I want interop with .NET. So FSharp, definitely in its, even more so in its earliest incarnations than now, was heavily tied into the .NET ecosystem. So, you know, the tooling was effectively part of Visual Studio. The packages you consumed were from the .NET package manager. Even in sort of .NET Core, the sort of latest cross-platform releases of .NET, you still rely on the .NET command line tools to do things like set up a project file that tells you, sort of which bits of code to compile into your project. And so again, when Alfonso was writing Fable, it's like, okay, I've got this idea for a JavaScript compiler. How do I do it? His takeaway was not, okay, I'm going to sort of try and create some super compact bytecode equivalent in JavaScript. His takeaway, well, there's this existing tool in the JavaScript world called Babel, which will take an AST, an abstract syntax tree, and it will turn it into cross-browser compatible JavaScript. Now, what most people do is they take a newer version of JavaScript and they use Babel to compile it so that it can be used on older browsers. But what Alfonso did was he said, well, it doesn't care where the AST comes from. So he kind of took the front end of the FSharp compiler up to where it creates the AST, sort of bowed out of the process there, where normally it would carry on and create .NET bytecode, and said, okay, I'm just going to pass that syntax tree to Babel, and then Babel will write cross-browser compatible JavaScript for me. And one of the side effects of this is because Babel tries to stay as close to that AST as it can, because if you're writing JavaScript and you're using Babel to translate it, when you're debugging that on some customer's web page and you're sort of over the phone asking them to spin up the developer console and try and tell you something, you want what they see to be very similar to what you see. And so if you go and play with Fable online and you start putting FSharp code in and you watch what JavaScript it compiles to, it actually compiles to what looks like pretty human-readable JavaScript. Evan, on the other hand, had a different set of problems to deal with. So obviously, having made this decision that his code needed to be pure, he wanted this kind of tool chain that took advantage of it. And so he wanted to build sort of a compiler that would create this kind of very optimized view. You've written this kind of event loop runtime, and the reason you've sort of insisted on a pure language is because you want to be able to optimize it. So you want to be able to optimize and compress and do all those things to that code in your compiler. So his compiler was written from scratch in Haskell. And one of the advantages he could take there was that he could start going, okay, well, just a minute, I can sort of leverage what I know about this language and what you're allowed to do in it to create really helpful error messages, which feeds back into his, it should be delightful to use. And then he went, well, okay, well, it's not like you can directly consume JavaScript packages in Elm anyway, because we have this purity restriction. So we're going to have our own package library. So how about, given that we have strongly typed pure packages, well, we can check programmatically whether this is a major or a minor change. If you make a breaking change to a package, we won't let you publish it unless it's got a new major version number. But obviously, we can only do that if all of the code going into that package library is Elm code, and if we control the package library. So it's like, okay, this whole thing sort of comes together. And then again, it kind of goes beyond Evan himself. He started sort of influencing the kind of people who chose to pick up Elm as a language. So then you get tools like Elm Format, which nearly everyone who writes Elm uses Elm Format, where it kind of automatically formats your source code. And it's really nice because as a team, you don't have any of those arguments about formatting. And if you're doing live coding, you can type complete gibberish and hit save, and it will like reformat it into a nice little slide you can show on a screen, which is great. That's probably not the main reason AV wrote Elm Format, but never mind. And so the tooling around Elm started to take on this same sort of characteristic of, we're going to be simple, we're going to be reliable, we're going to do one thing and we're going to do it well, and we're going to do it the Elm way, the way that fits with this ecosystem. And so that then kicks into the ecosystem that created around it. So I know one of the things Evan sometimes finds quite hard is that in some ways Elm has become quite contentious because it's very much still Evan's project. And I know he sometimes gets comments about, oh, it's not really open, you show us the code, but it's not really open source because you keep control over it. And there's a whole load of these discussions, whereas Elm is, Elm very much still is Evan going, I haven't finished this tool yet. I am crafting like a sort of a master craftsman, this tool to do this one thing. And I'm still in this process and I'm willing to listen to your ideas and I'm willing to listen to your use cases. But at the end of the day, we haven't got there yet. We're still building it. So, you know, that's his kind of view of where he's coming from. And so that kind of shapes the kind of people who want to use it and what they do with it. So you get this kind of, although Fable and Elm look very similar often in how they're used, because the F# community have kind of adopted this Elmish architecture for how they structure UIs, even in none sort of web page based applications, so, you know, sort of mobile and native apps. The libraries they consume to do it are very different. So in that example we saw right at the beginning, where effectively you had exactly the same code in Elm and Fable, in Elm, that code is kind of directly tied into the runtime. Whereas in Fable, all it actually is it's a very thin wrapper on top of React to create the view and Redux to handle the event loop. And this sort of carries across the whole way. You know, it's like you can directly reference Yarn packages in your Fable project and just use them. Yeah, you need to sort of throw some types in, but it's not hard to do it. In the same way that with F#, if you want to consume a library that was written in C#, you just reference it and you just use it. Whereas Elm has a very different sort of outlook on this. So in F# you get immediate access to this huge JavaScript ecosystem with all of the availability of, you know, pretty much anything. There's at least one implementation of it. But then there's the question of, do I actually want to use that implementation of it? And will someone publish a major update next week that breaks it? Whereas with Elm, you kind of have this very constrained package library, both in size, because the community isn't huge, and in terms of what it implements, because pretty much in Elm, you generally want to rewrite something from the ground up to like follow the constraints that Elm gives you, rather than just kind of modify a JavaScript library. And because of these constraints around sort of semantic versioning, you know, sort of enforced semantic versioning. So you may not find the thing that you want, but you will generally, if you do find something, it will generally be of quite high quality, and it generally won't break you at some point in the future. And the other thing that it affects, which again, I think comes down quite a lot to the personality of the people involved, is the naming of packages. So Elm actually has an explicit preference in its package library that packages should have a very prosaic name. The name should say exactly what the thing does. And so you'll get lots of GitHub projects called things like Elm GraphQL, which is the Elm library for calling GraphQL APIs. Whereas in F#, you tend to get lots of bad puns on the letter F, or things named after Greek gods. So there you go. And finally, I just wanted to say that thing which I think surprised me most, having moved from writing F# for a long time, I've now spent 6 months with a team writing Elm for the day job, is just how much it kind of shifts the team dynamic. You know, Python has this thing of there should be one, and preferably only one, obvious way of writing a piece of code. Elm kind of takes that to a whole new level, especially if you're using Elm format, because it even applies to your formatting. And that's amazing for working on big teams and big projects with people new to the language, because you come in and a week later, you know that you can open any Elm file anywhere in your project and you will have a very good idea of how it works and how it's been implemented. Whereas with Fable, you kind of have a bit more room to express yourself, you know, down to and including just randomly inlining bits of JavaScript from other libraries because you feel like it. Now, obviously, you don't want to do that on teams too often, but it's there and it's kind of tempting and you can play with it. So, you know, you'll see what happens. It's a feature, yes. And so I got asked, I'll sort of put that up for now because I know I need to stop in a moment. But I got asked about 2 months after I started writing Elm, it's like, what do you think of Elm? You know, how do you compare it to F#? And the answer was really strange because I've worked as kind of a technical architect at a company, and I suddenly realized that I had two totally different opinions depending which hat I was wearing. And it was like, if I'm the technical architect and I'm making a sort of business design decision for the next 5 years and I'm going to have a team of 30 people, I would probably go for Elm. You know, it's nice. It onboards you quickly. It makes it very hard not to write maintainable code. You're really quick to bring people into the project or move to another area of the project. But if I'm going to hack something together next weekend to try out a new idea, I'll probably be doing that in Fable. because actually I like computational expressions, and sometimes I want to inline my JavaScript, and yeah. So there you go. And yeah, that's it. I'm right at time, so you can come and find me afterwards if you've got questions, I think. But thank you very much. That's who we're working for at the moment. We pay Evan. We're hiring remotely, so if you're interested, come and talk to me or Ju, who's around somewhere, or Michael, who isn't wearing the t-shirt. Slacker. And thank you very much.